What up guys, B-Hepz here, and today I'm going to show you how to use the quadratic formula for math and like solving math problems with it. Okay, so I'm sure we all know what the quadratic is, but I'm just going to write it up here for a little reference. So it's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so that's your quadratic right there. It's basically, what it is. And there's multiple parts to the quadratic formula. The most important is probably going to be the discriminant. And so the discriminant is basically the b squared minus 4ac part. You're not worrying about the square root part of it though, just the b squared minus 4ac. Now, basically what the discriminant does is it'll tell you whether there are two roots, one root, and two complex roots, which basically means if you get a negative number, like for example negative 31, that's going to be complex and not really like rational. So yeah, the problem we're going to be working off today is going to be x squared, just write it up here, minus 7x plus 6. Alright, so that's the trinomial we're going to be working off today. And I'm sure you guys all know what the letters are of the quadratic, but maybe some of you don't, so I'm just going to say A, B, and C basically correspond to the trinomial here, where A is the value of this, B is the value of this, and C is going to be the value of this there. Okay, so A, B, C, when you're working with a trinomial. Alright, so the first thing I'm going to go ahead and do is I'm going to pull the discriminant out of the quadratic, so your b squared minus 4ac, okay, that's your discriminant. And I'm just going to go ahead and plug numbers in here. So for b I'm going to put 7, so 7 squared minus 4. So for A, that's going to be 1, even though it's x has a value of 1. 1. And for C, it's going to be 6. So you see what I did there? C, 6, 6. A is 1, 1. And B is negative 7. So negative 7. Doesn't really matter with the negative here because we're going to square it anyway. So, yeah. You just leave it like that. Okay, so if we go ahead and solve for the discriminant, we're going to get 49 minus, I think 24. Yeah, okay, 49 minus 24, and that's going to give you 25. That's a nice number. So by solving the discriminant, we have determined that this positive number is going to have two roots because it's positive, like it says right here. See, it's positive, two real roots. Okay, so now that we've just basically solved for this part, we can just go ahead and plug the numbers, all the numbers, into the entire quadratic and just start solving for the zeros. So I'm going to go ahead here and do x equals 7, because a negative and a negative cancel out, plus or minus square root of 25. See, that's just what we solved for with the discriminant, over 2a. And since a is just 1, I'm just going to write 2. It's all over 2. Alright, so we can just start solving it out here like normally. So I'm just going to simplify things a little more. 7 plus or minus 5, everything squared, or divided by 2. Alright, so you're going to get 2 answers for x, so I'm just going to draw 2 x's here. And for one of them, it's just going to be 7 plus 5 divided by 2. It's going to be 6, alright? And for the other one, I'm going 7 minus 5 over 2. So 7 minus 5 over 2 is going to be 1. Alright, there are your zeros. Okay, so now if we want, we can go to like a graph or something, and we're going to know where the x-intercepts are on the graph. So let's just plot 2 points here. That makes sense. Just say that this is 1 and this is 6. And yeah, we can just go ahead and find the x values on the graph using the zeros we just found using the quadratic formula. Okay, so I hope that explains everything. Yeah, and thanks for watching.